We're going to look at section 9.3 today, which is the slope-intercept form of the line. And it's in the form y equals mx plus b. So to start off, let's look at what slope is. The slope of the line is a measure of how the line increases or decreases as it moves from left to right. Some other words for slope are grade or pitch. Grade is often used describing the steepness of a road or a hill. Road signs are placed along a road to inform cars and trucks that there is a steep grade ahead. Pitch is often used in architecture when referring to the slope of a roof. On a graph, slope can be thought of in terms of right triangles, where the hypotenuse represents a segment of a line. The height of the triangle represents the rise, and the length of the base of the triangle represents the run. Graphs should be read from left to right. This means that if the line is sloping downhill, the rise will be negative, and if the line is sloping uphill, the rise will be a positive value. So here's an example of looking at the slope in terms of right triangles. And so if you were looking at a line that was a graph, it would be that hypotenuse, which is the side opposite your right angle. So that would be one equation's line. And then this one here would be a different equation for a different line. And so first it asks, is the slope of the hypotenuse of triangle A, which is the top triangle, increasing or decreasing as it goes from left to right? So if we start down here in the corner and move to the right, we're going uphill, and so that means it is increasing. What is the value of the rise for triangle A? Remember, the rise is how far up it goes, and so on the side here it is going up 4. The value of the run, how long we're going from the first point to the second point across the bottom, is 10. And now they're asking us to look at the slope of triangle B. So the bottom triangle is triangle B. So left to right, we're sliding downhill. And so it's a decreasing slope. I was going to type decreasing, I guess. The value of the rise, notice we're not rising up, we're dropping. So that's shown by a negative. So it's going down 6 spaces. So we'll show that by a -6. And run, we're still going to the right. This time we're going 15 spaces to the right. One way to calculate the slope is to divide the rise by the run. And remember, division is often used as a fraction. And so we'll be writing rise over run, and it reminds us to reduce fractions when possible. And so the slope of hypotenuse A, remember, we had a rise of 4 and a run of 10. And that can simplify down to 2/5. So the slope of the line from triangle A is 2/5. From B, we had a -6 for our rise, and our run was 15. And so that can simplify. We can divide each by 3. So we're going to get -2 over 5. There we go. And so for our slope of the triangle that we had it decreasing from left to right, we will have a negative slope. So when you have a line that is decreasing from left to right, you will have a negative slope. So here's the actual formulas to look at that. And so we can calculate a slope of a line by figuring out that rise and run, looking at two different points on the line. We have x sub 1 and y sub 1 and x sub 2, y sub 2, just to show two different points on the line. The slope, the symbol for the slope is m. It stands for some French word that means slope. I'm not sure what the word manche something. But anyway, we said it's the rise over run. The rise we know is up and down. The up and down is the y-axis, so that's why we're going to subtract y values on the top. And then the run is left or right, so the x values on the bottom. And notice they have it in two different ways. You have to be consistent, just like when we were setting up our proportions. Here they have the second ordered pair minus the first ordered pair, second ordered pair minus the first ordered pair for the y's and x's, and then this one is just switched around. So what they're telling you, it doesn't matter which point you pick first to do your subtraction, as long as you pick that point consistently first. So ordered pair. So if I chose the first y minus y, then I have to go to the first x when I do x minus x. And so this is generally how you will see this formula for the slope written, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But again, it doesn't matter which one you think of as your first point versus your second point, as long as you keep the order the same. So to find the slope of a line from a graph, first it says to find 2 points on a line. Choose one of the points to represent x1 and y1, the other x2, y2, and then substitute the coordinates into either slope formula and simplify. Well, honestly, this is saying find the slope of a line from a graph. If it's a graph, I just count, and I'll show you that. It's when they don't give you a graph and they only give you ordered pairs that you actually have to use this formula. And so, for example, here, since it's a graph, I would just count how I would go up and over and even necessarily draw a triangle in to get from one point to another. But if they just give you the ordered pairs, you have no choice but to do the math with your slope formula. Well, let's take a look at what they want us to do with this specific problem. It says use a graph to determine the slope of the line. Find the ordered pairs that correspond to each point on the line. So they want us to identify those points. So for our first point, A, we are at backwards 5, so -5, down 4, so -4. Point B, to get there, we're going backwards and down again, so we're going to have two negative numbers. And this one is backwards 2, down 2. So -2, comma, -2. Now let's look at C. We are not going up or down, so we're going to have a 0, since it's an x-intercept, 0 for y. But we're going right 1 and then not up or down. So 1, comma, 0 is the correct ordered pair form for that. And then for our last point, D, we are going to the right 4 spaces and up 2, so 4, 2. So mathematically, to find the slope from points A and B, you're using these 2 points here. And so again, we're going to do the y values subtracted on the top and the x values subtracted on the bottom. And so let's call our A our y sub 1 and x sub 1, and our B y sub 2 and x sub 2. And so again, the pattern is subtracting the x values, but again, I always was taught it's y sub 2 minus y sub 1. So since we picked this one as y sub 2, I'll start with the -2. And we're subtracting off -4. And then since we started with a -2, remember we have to start with a B point for the x value, so we're going to do -2 again, and we're subtracting off -5. -2 subtract -4 ends up being -2 plus 4, which is a +2. And -2 minus -5 is the same as -2 plus 5, which is 3. So our slope is 2/3. So m equals 2/3. So it's telling us to go up 2 boxes and right 3 boxes. So watch. Up 2, right 1, 2, 3. We'll land us at point B. If we do the same thing using points C and D, this time let's start with the C first, and we'll do C points subtracting D points. So for our y value we have 0. We're subtracting off the y value of 2 over x value of 1. Subtract off the x value of 4. 0 minus 2 is -2. 1 minus 4 is -3. 2 negatives make a positive. A negative divided by negative is a positive. But we will leave it in fraction form and just simplify it by taking out the 2 negatives. So again, that's telling us to get from point C to point D, we're going up 2 boxes and right 3. So we can see that they are the same slope, which makes sense because they're from the same line. And so do you think it matters which points on the line are used to find the slope of the line? Explain why or why not. So it doesn't matter because the rise and run are the same for the entire line. So to show that, for example, let's say we used points A and D to calculate the slope. And so we'll do D minus A points for that. So we would do our 2 subtract -4 for our y minus y. And so since we started with the 2, we have to start with a 4 on the bottom. So 4 minus -5. 2 minus -4 is 6. And then 4 minus -5 is 9. That doesn't look like it matches. 6/9 isn't 2/3 until you simplify. 6 divided by 3 is 2, and 9 divided by 3 is 3. So you still get the same slope. So even if you're going from A to D, we saw that that was up 6 and right 9. It simplifies down to the 2/3. So again, as I was mentioning, when I'm given a graph, I just count. And so usually they're not going to show you the different points like that. So what I would do is I would find a point that works perfectly. And let's try and even find one that's not on there. So here, find one where it crosses perfectly in the corner and slide up my line until I find the next time that it crosses perfectly in the corner. Again, a whole number x and a whole number y value. And then I count. What do I need to get there? 1, 2. So my rise is 2 over 1, 2, 3 over a run of 3. So our slope is 2/3. So again, it doesn't matter if you pick 2 points that are right next to each other or not, meaning the next whole number. As we showed here, we can go from A to D. It just means you have to simplify your answer some. But any 2 points along the line will work when doing the math to solve for the points. Let's take a look at some math that they gave us and see what, if any, mistakes they made, and we'll fix them if they're wrong. So we have 2/3 and 2, 3, and 4, 9 as our 2 ordered pairs. So notice no graphs are given. We have to rely on our math skills to get the slopes. We can't just look and count. So on the top we have 2 minus 4. They did x minus x. These are x's, not y's. We're supposed to do y over x. And so we can keep that order and we'll do the 3 minus the 9 over the 2 minus the 4. So they just reversed it. So they did the reciprocal. And so if we flip that, we're going to get, oh, they also made another mistake. Notice 2 minus 4 is negative 2. And 3 minus 9 is negative 6. So you still end up with positive numbers, but their subtraction here they showed wrong. And so this would give us positive 3 over 1 if we were to simplify. Anytime you have anything written over 1, we know anything divided by 1 stays the same. So to simplify that, we'll just say that we have a slope of 3. So whenever you're given a slope of a whole number, you can think of it as a fraction over 1. So if you have a slope, for example, of negative 6, that's going to tell you to go down 6 spaces and then write that invisible 1. Because again, we can put it over 1. Okay, so that's just an example of a slope that's not written in fraction form. Okay, let's check number 5 now. We have 5 minus 4, so they did this point first, this point second. On the bottom, we should do 3. They switched the order. We should have done 3 minus 1, which would give us a positive 2. So to fix it, it would have been a positive. So notice what happens if you switch the order of your points from your A values or from your Y values to your X values. It gives you the wrong sign. It gives you negative slope and your line is actually positive slope. So make sure you're choosing that right order for your ordered pairs. Now there's 2 special cases when we have a slope. We have our vertical lines, which are up and down, and our horizontal lines, which are left and right. So your vertical lines are parallel to the y-axis. We know the y goes up and down, so it's never going to cross that y. So look at the equation. Vertical lines have the form of x equals a, where x is the x-intercept. And so when I think of this, when I look at a line that's given as a picture, it's parallel to the y, so there's no y in the equation. So it's going to be x equals, and then see where it crosses the x-axis. And so no y parallel to y. Horizontal lines, it's going left and right, so it's going to be parallel to the x-axis. And so the equation does not have an x in it because it's never going to cross the x-axis. Unless you get it to where y equals 0, then it's going to go right along the x-axis. And so you have straight up and down, straight left to right. And so it's saying we have unique slopes for these. And notice I divided this. This is A and C. So we're going to kind of skip around the questions to answer the 2 that relate to each other for this question. So find 2 points on line B to determine the slope. So let's pick this point here. Now let's pick our intercept here. And so for that, we're having points -1, -2, -3, -4, 0, and this one is -4, 3. And so if we look at the math involved, we're going to say y minus y. So let's do 0 minus 3. And then on the bottom, we have x minus x, which is -4, subtract -4. And so we get 0, -3 over 0. We're not allowed to divide by 0. So anytime you have a vertical line, it is an undefined slope. Let me type that. Oops. Instead of trying to write that because it's going to be very sloppy if I don't. So an up and down, see, we're going a rise of 3 spaces, but we're not running anywhere. So your slope of a vertical line is undefined. And it's showing that for this, it has no y-intercept, like I mentioned before. No y is parallel to the y. Okay. So let's look at h. H is a vertical line. And so if we determine the slope of this one, let's pick a point here and here. So we have 1, 2, 3, 0. Oh, sorry, I reversed that. We're going left to right, 0, up 3. And this one we went right 3, up 3. And so if we're subtracting, we'll have our y minus y over x minus x. So we get 0 on the top instead of on the bottom over 3. So that's just 0. And so your slope of a horizontal line is 0. Okay, so let's review that. So let's put it on here. So when you look at this, vertical lines have a undefined slope, and horizontal lines have a 0 slope. And the way I remember the difference between the two is that there's an O in horizontal that is my 0 for my slope. That's how I remember. And the vertical line is undefined. The horizontal is my 0 for my slopes. So now that we've talked about slopes, let's look at the actual form of the line that is called the slope-intercept form. And the equation is y equals mx plus b. So remember, before we had that standard equation, ax plus by equals c. Here they're using a different variable that represents the number or the coefficient in front of the x, because if y is by itself, that number in front of your x is your slope. That's why that m is there. And we mentioned m represents slope. And b is your y-intercept. It's the coordinate value for your y-intercept, because if we plug in 0 for x, which we know x is 0 and the y-intercept, you can see y will equal your b value. So that's where you put your y-intercept on your graph. Each line on a coordinate plane is unique, but it can be represented by many different equations. Each equation that represents a specific line has the same solution set, which consists of all points on the line. Because these equations have the same solution set, they are technically the same equation. The quote different equations, which are called forms, are the same equation but rearranged to look different. Certain forms have specific uses. For instance, when an equation is written in slope-intercept form, it's easy to determine the slope and the y-intercept of the line, and so it's easy to graph it if it's in this form. And so the slope-intercept form of an equation can be found from the standard form of the equation by solving that ax plus by equals c formula for the variable y, as long as b cannot equal 0, because remember, we can't divide by 0 to get a slope that's undefined. So we're going to take the equation 6x plus 3y equals 12 and put it in our slope-intercept form. And so here we have 6x plus 3y equals 12. We've done solving for a variable before. We want y by itself. So first we have to move that 6x over. And so we're going to subtract 6x from both sides. So we're left with 3y on the left. And we'll keep it in the mx plus b form by putting our negative 6x first and plus 12, since 12 is positive. So we want the x value written first. Notice I didn't do 12 minus 6 is 6 because they're not like terms. The 12 is a constant, 6 has a variable x with it. So all I can do is write them next to each other. And then again, we want to get the y by itself, so the last thing we need to do is divide by 3. Now remember, everything has to get divided by 3. So we're going to put divide by 3 over here, and the whole thing over here is divided by 3. I like to break it up and show each one individually divided by 3. It helps me do my math better. And so y equals negative 2x plus 4. That is my equation in slope-intercept form. Okay, so we can see for this line, the slope is negative 2. And again, if we want to think of it as rise over run, we could put it over 1. And then our y-intercept, which according to the formula is a b value, it's at 4. So as an ordered pair, we cross the y-axis at 0, 4. The slope-intercept form of an equation can be found from the graph of the line. Use the graph to work through the following problems. So determine the ordered pair that represents the y-intercept. So it crosses the y-axis right here, which is just up one space. So that's 0, 1. Because again, we didn't move left or right. Determine an ordered pair that represents a different point on the line. Let's come up here. Here's a point. And so to get there, we need to go 2 spaces over and 5 spaces up. And so again, when you are given a graph, I mean, we can do our 5 minus 1 to get 4, 2 minus 0 to get 2, and 4 divided by 2 is 2. Or we can look on this graph and count. So again, even if I didn't identify my y-intercept, you can find one point on the line. And if we slide up to another point that's on the line, we can see that we're going up 2 boxes over 1. So the slope is 2 over 1, which again, we'll simplify and just write it as 2. So when you're given a graph, you can actually just count for the slope. So now to write our equation in slope-intercept form, we put that as y equals our slope, which is 2, then our variable x, and then our y-intercept. And our y-intercept was at 1, so plus 1. That's how you build your equation, y equals slope, x, y-intercept. Okay, so here's some problems for you to practice. Notice up here, you're finding the slope given the point, so you can't just count because there's no graphs. And if you want to, dealing with these fractions, you can turn them into decimals and then just work with decimals in the equation. It might be a lot easier for you to do that way. And then down here, build your y equals mx plus b, plugging in your m value. And then for your b, it is the y coordinate of the y-intercept. When you're done working through these, check your work, and then we'll move on to the story problems. Here we have something close to home for our first application. The Millennium Force roller coaster at Cedar Point in Sandusky, Ohio, has been voted the best steel coaster by Golden Ticket 7 times since 2001. The Millennium Force is known for its steep slope on the first hill and speeds up to 93 miles per hour. The descent from the first hill starts at 310 feet above the ground and ends 10 feet above the ground. The descent runs approximately 53 feet. Find the slope of this hill to the nearest 100. And so it gives us a hint that we're going downhill. And how does it affect the slope? We can see it's going downhill. So we know that downhill means negative. So our run, our distance across, it tells us is about 53 feet. And then the rise, well, actually we're falling. Notice it's 310 feet above the ground, but we are stopping 10 feet. So this is really 300 feet of a drop. And so our slope is the rise, which again, we're going downhill. So it would be the fall of negative 300 feet across a distance of 53 feet. And so the slope of the hill, they want us to put it in a decimal form, round into the nearest 100, which is 2 decimal places. So our slope is negative 5.66 when we round 2 decimal places. For our next problem, the grade or slope of a road is commonly given as a percent. The grade can be determined by multiplying the slope by 100. So decimal to percent, multiply by 100. We've done that before. Calculate the slope of each road or track and then determine its grade. Round each percent to the nearest 100th in 2 decimal places when necessary. So the road increases in the height of 5, so that's our rise, and increases positive over 120 run. So again, we're going to divide that. 5 divided by 120 is 0.0417. In order to round to get 2 decimal places in a percent, we need 4 decimal places in this decimal part, because remember, multiplying by 100 moves that decimal place 2 spaces in. So in this case, we have a 4.17% grade of this hill. The railway line with the steepest grade that does not run on a track system in Lisbon tramway network in Portugal, which has a section which increases 5 feet. So again, it's going up 5 for every 37 feet of run. So if we divide 5 by 37, we get 0.1351. And so when we multiply by 100, we get 13.51%, which is very steep. A road on the route of ridges, I'm not even going to try and pronounce that in French because I can't speak French and my accent would just crush it. But in France has an elevation that increases in height of 450 feet over a run of 1,500 feet. So if we divide 450 by 1,500, we get 0.3. So we have a 30%. Okay. And now let's look at our last story problem. Jared sells paintings at an open air market. He starts his workday with $30 and he sells each painting for $15. Jared wants to create a linear equation to model the situation where Y is the amount of money Jared has at the end of the workday and X is the number of paintings sold. So the slope or rate of change is the increase in the amount of money Jared makes when he sells a painting. Determine the value of the slope and list the units for both variables. And so our slope is a rise of $15. and a run of one painting. So we can write that another way by just saying that it's 15 per painting. Just like our units that we were doing before, like per hour and things with our proportions, it's understood to be 1 hour. So per painting is understood to be per one painting. Now the y-coordinate of the y-intercept of this equation is the amount of money Jared has before he sells anything. So it tells us that he starts with $30, so that way he can make change if need be. So the b in our y equals mx plus b form is the symbol we use for the y-intercept, and that would be $30. So even if he hasn't sold anything, he still has his $30 that he started with. And so if we want to write that as an ordered pair, it would be 0 paintings sold. He has $30 in his pocket. So the linear equation for this would be y equals 15 for our slope, x times the number of paintings plus the $30 he started with. So here's our $15 per painting plus the starting amount. So again, y equals mx plus b form. Now we are supposed to graph the equation. So this is where it's nice. Notice they're counting here by tens on the y-axis, and they're counting by ones on the x-axis. And so our y-intercept was $30 when no paintings are sold. And then our slope is 15, which means we can go 15 over 1. So it means we're rising $15. Here's 10, halfway up would be 15 over 1 painting sold. And 5, 10, 15 over another painting sold. So notice we can use our slope to count to draw our line. And so if we pull in a line here, and technically, again, we are supposed to have arrows on both ends, but in this case, we really don't want to extend any further because, again, E reminds us that sometimes it doesn't make sense to use any and all equation answers from the number line because we will have no negative values. So no negative paintings, no negative dollars. And so what we're really doing is sticking again to this first quadrant for answers that make sense. And it says use the graph to determine the amount of money Jared will have after selling 4 paintings. So if we go over to 1, 2, 3, 4 paintings, we're up here, which is at $90. So again, we mathematically could have done that because 4 paintings times $15 each gives us $60 plus the $30 that he started with. But notice we didn't need to use that because we can look at our graph to determine that. Okay. So if you have any questions while you're working through the homework for 9.3, please email me, let me know. Don't forget to screenshot the questions so I know what you're asking about. Otherwise, I'll see you next time.